Мне 30 секунд.
Что?
Мне 30 секунд.
Я не могу, все
Уже не успеешь, да?
Потом.
Хорошо. Потому что я так добрался уже до следующего этапа, попал на то, что ничего никогда не нападает. Так, я поехал домой с Женей, потом возьму тебя запись.
Okay, да.
А ты пишешь, правда?
Угу. Hide. Go away. Okay. Shall we begin? So, thank you for coming, even though the weather was questionable. This time we're going to talk about microservices using Docker. It's quite a complex subject, apparently. I was not aware just how complex it is. So hopefully it will cover just enough for you to get familiar with microservices and get ideas of your own of how to continue implementing such an architecture. Anybody here who hasn't been on Docker introduction and doesn't know what Docker is, how Docker works? Please raise your hand.
It's an end or a fourth question.
Okay. So everybody knows what Docker is. Anybody who hasn't seen the link I posted a couple of hours ago on the meetup page about downloading extra images for your... So do it now. This is enough time. Okay, so anybody who doesn't know who I am, I'm Evgeny from DevOps Israel. And we provide consulting and services to companies in related fields to DevOps, etc., if that can be defined. So what we're going to talk today about today. Very short introduction to what are microservices. A comparison of architecture. Bensi. We're gonna write up 2 free services and start them up, which hopefully will be new to you, and that will be the workshop part. And cover a couple of best practices about microservice architectures that I gather up. It's not all of them, but it's some best practices. So as I sent the link on the meetup page, you can clone it's the same Vagrant file from before. There's a new URL for the cheat sheet that you can see on top of the screen. Docker-ws-2-cheat. From there, you can copy paste whenever I have a slide that has a lot of code on it, and you want to run that. You can copy paste from that place. It will appear on slides with code as well. And the additional part here that wasn't on the previous workshop is downloading a couple of images, pulling a couple of extra images. That might take time, so you might want to go to the cheat sheet or go to the link I sent on the meetup page and run this command now. Okay, can I go? Continue? So, microservices. Copy the definition from Adrian. It's loosely coupled service-oriented architecture with bounded context, which is complete gibberish in Chinese for people who don't know what is loosely coupled and what are bounded context. Hopefully everybody knows what is service-oriented. It's when you think in services way. So loosely coupled, yes? Slide back. I try to keep the URL short and memorable. Anyway, it will repeat later. Anyway, loosely coupled means that when you have a microservice architecture, you are not doing deploys of the whole application on a Friday night. Okay? If you are doing a deploy that includes everything, you probably don't have a microservice architecture. Bounded context means that every service knows as little as possible about its environment to do its job, to get its input and provide its output, but it doesn't need, if it doesn't need to know about the database, it doesn't know about the database. Okay? That way you can deploy them without breaking other stuff, and we'll talk about that in the best practices section. On some slides at the bottom, I'll send you the slides later, but there are links to the places where I reference this information from, so you can, if you're really interested in microservices, go later and check out all the videos and slides and blog posts that I kind of copied from. They appear on the bottom of the slides. So, why should we use microservices? Any ideas? Why is it a good thing?
Because you don't break everything at once.
Yes, because you don't break everything at once. You break small pieces when you do break stuff. More ideas why microservices are good. Yes, you can separate your deployments to be smaller chunks, smaller parts of the architecture. What else? Different development cycles, yes. Actually, you can have a very large organization with multiple teams. Each team work on their own service, and they don't need to synchronize as much, right? So, smaller code, microservices, well, at least that's the idea. Some people don't make small microservices. They make large ones, and that's not the idea. That's like counter micro. So it's easy to change and understand when something is broken and you need to fix it or you need to extend it. Faster start time. Okay, a bigger application takes a long time to start. We'll cover this at the end, but basically, different parts of your application care about different things. So when you want to change some feature somewhere about billing, you would not go and change the user registration. Okay, that they will not be connected. You can scale different parts of the architecture independently. Okay, like when you have a huge influx of user registrations, you can scale the user registration service separately from the other things. You can better fit the smaller services with the infrastructure. So when you need something that is CPU bound and memory bound, it fits. You can, of course, scale services that require a lot of memory on servers that provide more memory. And as we said previously, you can scale development teams. When you have lots of teams, everyone can work on different stuff and not have as much synchronization. Question? No? Okay. And when something breaks, as you said, it's isolated to a small part, hopefully not affecting the whole architecture, the whole application, whatever. And another thing is you get a flexibility about your technology stack. So if you want to write all your services in Ruby, but tomorrow you find out that maybe it's much easier, faster, better to write something in, I don't know, Node.js or Go or Python, because you have this isolation of services, you can do that. And we'll do this later. So why not? Why not do microservices? Why it's not such a good idea?
The answers are buggy.
Yes, I know. I didn't hide them. I know I hate bullet point slides, but I'm sorry. This is what I have at the moment. Yes. There is a lot of overhead and communication between processes. So when you break one request reply cycle into multiple request replies, you get it takes longer, maybe. We'll talk about that later. you also need to think about all this new stuff, like how do these services talk to each other that you didn't need to think about before. And when you have a transaction, when it spans multiple services, it becomes really hard to track and trace. Okay. And whatever is written, you can read it in a second, and I wouldn't need to read it all. As we said before, synchronization of teams, of people. Yeah. Yes. Yes, you can try out different versions of a service. That's an interesting added value. But as we said, microservices are quite complex and they are not so easy to manage. So for small companies, small startups, not many people, it's probably not a good idea to choose microservices on the get-go, because that will just take you a long time to get to market and get something done. Because you need to handle all this overhead that right now is not yet provided in a nice framework by DHH or someone. When in Rails, you can just take this thing and it has all this stuff inside, configuration and database and whatever. So let's touch a little bit about architecture of applications. Again, we have the infrastructure, right? We have cloud, we have load balancers, content delivery networks, web servers. Maybe we have a couple of tiers, so we also have application servers behind them and databases and et cetera, et cetera. And still, it doesn't mean that it's a microservice architecture, because still on the web services you would have monolithic applications that are being written by 100 people, and the same about the application servers, and you have the DBA team that manages the databases, and it's not small at all, right? And the services are big and they encapsulate a lot of stuff. So how does a monolithic application today looks like? Why is this interesting for us? Because we would need to have all this stuff in our microservices architecture that would be missing, right? So we have the application server, Ruby on Rails, Django, Spring, PHP, whatever it is. It usually contains both the presentation logic, how we generate the output, like a web page or API for some mobile or something. It has the business logic, usually, what we actually do with the user input and how we process data. It has some kind of data access, like an ORM or similar. Then we have databases that store data behind. And that as well might be MySQL, Postgres, Mongo, MS SQL, whatever it is. And when many people talk about microservices, they're saying, well, we're going to take and make asynchronous workers and add a queue, and the queue will be another service, and asynchronous workers will be another service, and now we have microservices architecture. That's a bit naive way of saying that they have a microservices architecture while they still have this monolithic Rails application running with this huge database and et cetera, et cetera. So why am I talking about monolithic applications? Because frameworks like Ruby on Rails provide you a lot of stuff. Yes, a question, a comment. Yes. Okay. Okay, so for whoever didn't hear it on the microphone, Avishai said that when you add a worker and a queue to an existing Ruby on Rails application, you still, in most of the times, deploy it as one whole, and it's part of the application. It's not really microservices architecture. which I agree with. As I said, people think it's microservices, but it's usually not. Now, monolithic applications provide you services. What services do they provide? You can serve static files, for example, with Django or Rails or Nginx, whatever. But you can serve static files. They generate these static files for you. Okay. Who is going to do that in your microservice architecture? You will need to find a way to do that yourself. There's a controller that connects the data with the view and provides views with the data that they need to render correctly, right? Who is going to do that in your microservice architecture? You will need to do that as a service yourself. There's a layout that is used by the application, by all the rendered pages. Who is going to do this central main layout for you? You're going to do that as a service yourself. There's a routes file in Ruby on Rails that says this HTTP endpoint goes to this controller and this goes to that controller. If everything is a small service, you would need to handle the routes part yourself. There are configuration files and maybe secrets and stuff. Yes?
Saying that if I have a Rails application, can be split into multiple microservices. As it is, I have to take care of every part that Rails does for me.
Well, not what. Okay, so the question is, when you have a Ruby on Rails, do I mean that you have to split it up to small microservices? As we'll see in the next, actually towards the end, in order to have this small service that you can deploy isolated from everything else, you want it to have as little responsibilities as possible. So if that service has a responsibility to give the information of who is your database to everybody else, and he's also responsible to render your views and HTML and etc., and he's also responsible to access to the database, right? That microservice has too many concerns that is concerned with, and when you want to change your database, for example, from, I don't know, Postgres to Mongo, you will need to touch that service because one of its concerns is the database. But you, like when you have a real microservice architecture, that your whole architecture is microservices, you don't want to touch something that renders when you want to change your database. You only want to touch the service that actually handles the database part.
That is true, but it's true. General speaking of design applications, we will have tiers anyway. We'll have a backend tier that talks to the database. That's one layer of your application, which is supposed to be by design totally different than the one that handles the API outside and the client side code.
Yes, but again, as I said on the first slide, which I don't remember, but if you want to talk about real microservices, they need to be so small that they only handle one concern, and you have lots of them. That's the idea, okay? You have lots of microservices, and when you want to deploy something, you only deploy that small thing, and it doesn't do anything else. When you have front-end and back-end servers, and you can maybe deploy the front-ends separate from the back-ends, that doesn't mean you have a microservices architecture. That only means you have, I don't know, 2 or 3 tier architecture. But when you want to change something in the back-end, then it affects a lot of stuff. It has a lot of concerns. It's a bit, I don't know, it's a bit hard for me to explain, but hopefully towards the next couple of slides we'll get a better grasp. A bit more. Ruby on Rails, for example, handles locales, right? Handles translation to other languages. That's a different concern. Why would that be part of your microservice service, like the microservice? It would be, it's okay to have it as part of your monolithic application, the bigger one. But as a microservice, that probably belongs to its own microservice that handles translation. Error pages, that's probably something that, again, needs to be handled by the error pages thing, the service, not by the big monolithic thing. Things like cookies and sessions and etc. etc. When you have lots and lots and lots and lots of sessions, and you have a bug in them, and you want to redeploy that small service that handles sessions, it's relatively easy and okay. But when you need to deploy the whole application for that, that becomes much more complex. At least that's the idea. Okay. So, what kind of microservices can you think about when you think about microservices? Some things are more architectural, infrastructural, and some are more application specific. So I wrote a list here. For example, configuration. What would be the benefit of having configuration separate as a service of its own? Any ideas? Yes, one central configuration. What else can it do?
Could have a nice versioning.
It can have versioning. It can be dynamic. It can change in real time. And you would only need to change the configuration. You wouldn't need to change all the other services because they would use this as a service. They would not have their own configuration at all. They would use the central configuration service, for example.
But will the configuration be pushed when it's been changed?
Well, you will decide how that service would behave. If you want that service to respond to an API that can get and put configuration into it, then yes, you can change stuff in real time. The router that defines which HTTP API endpoints lead where. Okay, what's the advantage of that being a service of its own? Any ideas? When you have a router service,
you can have multiple instances that do the same thing, and they can load balancing the
yes.
calls.
Well, you can for example load balance each URL. Each URL can be a different service, and each of those services can be scalable in their own small world. So if you have the user registration URL, no, I'm not talking about one or multiple. You have a router service. That service can be scaled to have 1,000 instances as well. No, they don't have to. They can be behind a load balancer service, which is another service. Because the router, it doesn't need to balance itself. It only needs to know how to route. It gets a request. It needs to know where that request should go. Okay? There's another service called load balancer that needs to know that if it gets a request, it sends it to the big cluster of routers that it has. That's a different service. Okay? And for example, in business logic services, so when you have something like authentication, that can be its own service, right? What's the advantage of having authentication as its own service?
Central authentication.
Central authentication, yes. What else?
Only one.
Authentication.
No, not authentication.
Yeah, we'll talk about it, but one of the infrastructure services can be service discovery as well. We'll actually create that in the. But what's good about authentication being a service of its own? Single sign-on, multiple backends, right? There's a lot of stuff you can do that when you start doing that in a monolithic application, that application gets really big and not really manageable, and you need to redeploy the application each time you need to fix a bug with authentication, etc., etc.
How would that work? You don't have centralized
authentication, you need to authenticate in a microservice.
So how would you do that? Otherwise, no. That's what I'm saying. You'll have one service that is responsible to for authentication.
I'm asking if there is no one service responsible for authentication, then application becomes responsible for each microservice. And
Then
you
authentication.
need some centralization. Otherwise, it's not usable.
I think you're confusing between authentication and authorization. Authentication doesn't need to be part of each of these other services. It only needs to be once. Then you authenticate against the whole architecture. You get a token, and with that token, you have authorization against various services, features, etc., etc. And that as well can be managed by one central service with backends. It can have, I don't know, an LDAP or a database or whatever. Is this user with this token allowed to do this action, etc., and return an answer? So hopefully, I know it's a bit hard to do this change in your mind. But the main idea about this is when you have smaller services, you can deploy them, you can add or remove features for them separately from the other application, the big one that you would usually have. Okay, and each one of those can have its own fault tolerance and scalability, etc., etc. And you wouldn't need to change the big application each time you want to change something in language translation or something. So it gives you a lot of flexibility, but it's probably only suitable for really big teams that have lots of people who can manage all of this, because it's a lot of management. And there's not enough tooling yet. Here I wrote a couple of types of microservices or of services that you can meet in the wild. For example, one of them would be handling the request from a user, and that would be synchronous. During that request cycle, a queue could receive some messages, and then some asynchronous workers can enrich the data or do stuff with the database. Databases themselves would be, again, looked at as a service. And at the end, you see you can either, for example, a service can encapsulate its own database, so it wouldn't be visible towards the outside world, or several services could share a database, but not recommended, I guess. But again, it's not set in stone.
In this case, it's only one service, or it's two services?
These are service types. You could have like a whole workflow of services, and these would be handling a request, and that would be, I don't know, you could call that a synchronized services. Services that handle one request and return a reply in the end. So these are types of services that you might meet. Okay. Now, this is a workshop after all, so we'll try to workshop something. And let's try and install Service Discovery Service. What is a Service Discovery Service? Anyone? Easy? Yes? You can discover services with it. What else can you do with it?
You can discover the service that does service discovery service.
As we said, you can discover services with it. What else can you do with it? Yes, you can register with it and say, I'm a service, register me. Okay. So it handles service registration and discovery. And if you're familiar with the implementations of this, there are quite a lot. Here's a list: Zookeeper, Eureka, etc., etc. We're going to touch. You can do that with your database. Maybe don't do that. We're going to install Consul. Anybody already uses Consul and knows how to use it? 2 people. Great, excellent. Let's install Consul. First of all, verify that in your Vagrant file you have the port forwarding, that you got the latest Vagrant file. It's in the cheat sheet. The cheat sheet link is up there. Well, actually, it's not in the cheat sheet. It's in the Vagrant file link. Yes. And you need to Vagrant reload if you didn't have that. This command.
That's the workspace button.
Yes. Just check that you have these 3 lines inside. If you clone that today, you're supposed to have them. Okay. So I look at my Vagrant file. See, these 3 lines are here. Okay. Fine. Next, this is preparation for console. It's not yet console itself, but we're gonna use this to access the web UI and stuff. Now we need to change the boot to Docker Vagrant and add some extra arguments for it, so it would use console as its DNS server. Because actually, is anybody who heard about console just now and doesn't know what it is? Ah, so I need to explain a bit about console. Let's explain a bit. So console, as we said, it registers services. You can register services with it, and you can discover services with it. It has different additional features like a key value storage, which is basically a configuration service inside. It can work on multiple data centers and regions and synchronize data between them for discovery, right? So you can discover services running in a different data center. And it has several query interfaces. One of them is DNS. So you can just ask, what is the web front end? And it would return you the web front end servers. The other is REST API. So you can just query an API in a key value store and get in response the list of servers, etc. We'll see this. And it also has a web interface which we'll use. So in order to use the DNS API, we'll need to change the Docker inside of boot to Docker Vagrant to have the extra argument.
You go back to the Vagrant file configuration.
Just go to the
It's not on the page.
Yeah, but you have the link to the Vagrant file, the workspace on top. So there's a link. You need to create it. It's not there. The profile file is used by the service, the init docker script, but it's not there initially. And what it does basically, when you restart the Docker service daemon, when you start containers with it, it would give them these DNS entries in their resolve conf.
Wait, I don't see this page in the cheat.
No?
There's a link.
It's not there?
No, there's a link.
No, it's there.
You have to click. There's a GitHub link,
No.
which you click and then you get to it.
Yeah, there's the Vagrant file.
How do I save it? I'm going to save it.
You're using this cheat sheet? WS2.
Is it over as permission that I should save it there?
But I just have the Vagrant file. Not
Did you do sudo vi?
This item.
It says sudo on the screen. So when you do this and you look at the process list, let's see. Let's go SSH into my virtual machine. Ouch, I have lots of them. So this is the Docker daemon, right? Okay, enlarge this. This is the Docker daemon, and you should see it with the --- DNS options that you wrote in extra args once you stop and start. Anybody got this far? Works? No one? Restart doesn't work, so you have to stop and start it. At least it didn't work for me. So if you tried restart, you need to start it again.
I'm still downloading the thing.
What thing? Ubuntu Docker?
No, not with Docker. The pulling of the images.
The original images, it's
Oh, you can do this. Ah, well, it will stop the downloads, but
Yeah.
it's okay.
Okay.
Yeah.
What? Oh, okay, you're done. I'm going to do it. This? What? Scroll down.
Okay, anybody done yet? Come on, let me turn the slide.
We added these values that you see in the Docker run argument that functionally has and then we run a container continuous console. How is that? So it's affected by that.
Okay.
Also will be aware of this DNS.
Okay, so let me show you what this does. So you have the Docker daemon, right? Working with these DNS arguments. Now I can run large this. Now I can run a container. This container, in its resolution, will get these values. That's it. That's what it does. All containers will get this. But of course, when you try to access this first IP, nothing is answering the DNS there because yes, because this is the IP of the bridge, of the Docker 0 bridge. And all the containers can access the bridge, right? They can. That's the default route. Okay. Anybody needs explanations about default routes?
same machine.
Yes, it's only on the same machine. Yes. But it's okay. You can run a console container on each host, and then you can cluster them together. They can find each other and talk to each other. That's the idea. But right now we're doing this on one machine. Yes.
So we haven't started console.
No. Is this done? Docker is running with the new DNS settings. Yes. Great. Let's run console again. You have it now. What is this doing? As you can see, it maps. Oh, that doesn't work. It maps the port 53 UDP to the host, basically. Okay, which means that any DNS client asking any of the host IPs for DNS queries would get a console to answer. That's the DNS server. And this is because of the fourth line here, the port mapping of 8600 to 53. it also, the last line here, advertise on, is this correct? Yeah, no, it's supposed to be 42, I think. It's supposed to be 42, sorry, here. It makes console tell everybody else, look, I'm running on this IP. Usually it would report its own container IP, which is not .1, which would be I don't know, 2, 3, 4, whatever. But this makes it advertise itself as, okay, I'm console. If you want to talk to me, talk to the bridge, basically. Talk to the Docker bridge. Anybody got this running? Docker start console. So here I have the console started, and as you can see, it forwards some ports, including the 8600. Anybody got this? Works? If you didn't download the images, that might take a while because of the image download when you run it. Works? Yes, good. Now, if you remember this port 8500 from the VM was mapped to 60,085 on my own Mac. So basically, I can now go to 60,085/UI, and I have console. Let's make it larger. Now it shows which services are running. So I have the console service, and it shows on which nodes the service is running. There's one node. Again, as I said before, console can cluster across multiple nodes. It would still be one service, but it will be a cluster of nodes that might even be in different data centers and different regions of the world. Okay? So when you click the service, or double click something. No. There's just, console reports itself. It says, I'm console, I'm reporting myself, I registered myself with myself, and that's it. Okay? Now, how would other services register with it? They probably wouldn't unless they know how to talk to console and register with it.
Can you show us again how to find your code that you register? The host to Docker.
Again?
Host to Docker port.
The Vagrant thing?
The Vagrant file.
The Vagrant file is mapping boot to Docker 8500 to my Mac 60,085. That's because I want to use a browser, and I don't have a browser in the boot to Docker VM. Okay? So, anybody has their browser showing console? 1, 2, 3. Excellent. Now, let's move to the next slide. The same guy who wrote this nice Docker image for console also wrote an application called Registrator. What Registrator does, it listens on events coming from Docker. Docker has an event API. Basically, you listen on it, and you get JSON events describing what happened. A container was run, an image was removed, etc., etc. So what it does, it listens on events, and each time it sees a server that has some ports published, it registers it into console automatically. It can also register to Zookeeper and Eureka and whatever, any kinds of other service discovery tools, etcd. So it has multiple backends. what it does, it listens on Docker and it registers stuff. Anybody has this running as well? I know you have the cheat sheet, so you probably already copy-pasted it, no?
Still missing a few images.
Ah, sorry to hear that. So let me run it. Docker run start registrator. So I have this registrator. Now let's look on its output. Docker logs registrator. It shows that it's listening to events and it registers stuff. It inspects containers, and right now I have 2 containers running, the registrator and the console, and it registers them. So when I go to my console web UI and I refresh it, I have more services. See? They got created by registrator. It says I have a DNS console service, which is tagged as UDP. What registrator? It listens on events of Docker, and each time it sees a container running that publishes a port, for example, our console publishes the port 53, it registrates that into console. Okay? As you can see, this registrator gets a parameter that says, send your events to console. It can also send events, as I said, to other backends, etcd, etc.
What is the E parameter that you run the registrator?
This is environment. It creates an environment variable that is for this Docker run. Okay? Yes, and registrator will load this up, and you will know that this is the Docker host it needs to connect to listen to events. So it will connect to this Docker host and listen on events on this Docker host.
So if I have a configuration that fits on different nodes, which everyone has a Docker host, on each host I need to have this kind of registration. Because
The registrator can connect to any Docker host, as you can see here.
So I can have multiple.
So if you have access to some way to access the other host's Docker API, you can run all your registrators on one host, and they will just query all the APIs. If you like, you don't have to. It's a microservice. It doesn't care about its environment much. It gets all its parameters that it has to know as inputs. So it doesn't assume that it runs in Docker. Okay? It connects to the Docker events that you say. Okay, so let's just do one more thing and then we'll take a short break because we have the noise thing again. So let's create a service. Now we will call this service a web server. We will give it a tag. But it's not actually a web server, it's just a shell, but still we'll call it a web server. So let's create it. Okay, I have a service now. And when I refresh my console, it's already registered and it has this tag and it says that this service is running on this one node that I have, which is the one host that I have, the one console. Any questions? You get it? It's cool.
I'm waiting for
Yeah, but you know service discovery now? You know how it works?
I have a general idea.
Yes, as you can see, we ran a web server that listens to port 9000. Registrator loads that up on its own. Let's see. See, registrator added my web server with its port, and now that I exited the container, it removed it. Well,
Also, it shows container name. Console dash.
yeah.
It shows dash.
I don't know. Let's try to run multiple ports. So we have the 9000, and let's try to have 10,000 as well. Press refresh. No, that didn't do what I. Yeah, that was unexpected. Anyway, let's have a break until 7:30. Hopefully it will clear out. Okay, and we'll start up another service. We covered that last time. Yeah? Huh?
מצגת, אתה יכול לספר?
בסוף.
בסוף? לא, בסדר, יש גם ביקשו לשאול.
ובמקום שתדעו להקשיב יותר, ולא לבטל את האחר, עכשיו אני אנשים יותר טובים. אני ומורה לא דיברנו כמה שנים טובות, כי הרבה מורים היו באים אלינו, כאילו, ואומרים לנו, בואו ננסה, והן אומרות, כאילו, אין מצב, זה לא יקרה. ואורלי לעומת זאת, כאילו, בא, טוב, אין מצב פעם ראשונה, אין מצב פעם שנייה, פעם עשירית, אולי יש לך מה לדבר. למקום כזה, לרגע. שגם פה, גם לא
Slide. Okay, let's continue. So, any questions or comments for Registrator? Do you like it? No emotions, nothing? So, as you can see, this Registrator, again, it has multiple backends. It doesn't necessarily know that it runs in Docker. You provide the Docker endpoint to it. So you can treat that as a microservice in some terms. Console, because it has multiple concerns, like health checking and web UI, and et cetera, that's a little bit of less of a microservice, but still. A couple more words about the console that I talked about during the break. They also have an add-on called console templates, which basically each time something changes in console, it can generate a new configuration file for HAProxy, Nginx, Varnish, whatever it is that you want to generate, embed the values from console in that template file, and there's console triggers that can reload Nginx. So it's like live configuration management. Instead of Chef running every half an hour and changing your configuration files to the new values, console can do that in semi-real time. So you can build a load balancer like this, for example, etc. So let's talk about communication, how the services can talk to each other. As this image shows, they don't have to talk the same way, all the services. They don't have to talk with the same protocol. So if you have a database and you treat that as a service, you can talk SQL to it. And when you have services that you want to have a binary fast protocol between them, you can use protobuf. But for this workshop and presentation, we will try and limit ourselves to HTTP and REST. So I will not go into in length what REST is, because hopefully all of you know. But basically, you have endpoints, and you have verbs, and lots of languages can talk REST and consume REST and provide REST. Okay, so there's all this versioning and resources and everything that how to design REST APIs that I will not go into, because that's a different presentation. So, what kinds of communication do we have in an architecture of multiple microservices? So some communication comes from the users. So users can request our endpoints, and endpoints can reply with HTML, with JSON, with whatever it is, with files, with images. You could probably at the endpoints, you probably want to have a layout, for example, for HTML that will define the header, footer, etc. For APIs, you might want things like JSON or whatever it is that you want to talk from your mobile applications to the backend service. Then we have inner service communication. Services talking to other services. You can choose to use JSON for that, but that's probably slow. You can use protobuf or whatever. And at some instances, we have events that coming from example from Facebook or from Docker events or whatever that you listen to with WebSockets, and you need to have this whole other system of communication, either that textual or not textual, to have some services maybe polling some external service. So you would connect outside of your architecture to get some information from outside. There are probably a lot of other types of communication in services. Depending on your application, you would know best. But these are a couple of them, 3 of them. Now, what is the most simple service that replies to HTTP that you can write? Okay, so this is a service. It runs. It's written in Ruby. It replies with "Hello World" when you run it. You want to try to run this? There's a whole. You can run that in a Ruby container. So the added benefit of Docker in here that you can have one service running in Ruby and maybe another service running in Python. Different containers, both of them do more or less the same thing. They reply hello world, 200OK, content type, text HTML. They serve themselves on some web port. This does the same thing when you do rack up. It wraps it in a web server. I thought maybe if this is new to you, you could run it. Do you want to skip this? Silence. Nobody wants to talk to you. Yeah, there's a. I copied pasted it into the cheat sheet. So you can do docker run Ruby bash and then paste this code inside, and you will have a web server, and that would be a service. The hello world service. Well, if you if you map the port 9292 because that's the default record port outside of the container with -p or -p large P, then registrator will get that, and you can name your service hello world service. So let's do this. 1 sec. Okay. I'm downloading images. Bummer. So I want to map my 9292 port. I want to name my service Ruby hello, and okay, about tags. Host name, that's interesting. Ruby hello. Ruby. Okay. Now, copy this into a file. Install rack. Come on, install rack. Ah, here we go. Add into Ruby hello RP. This up Ruby hello. Ah. What did I do wrong? Anybody knows Ruby?
But the same thing.
I tested it somehow. Sucks.
Shall we here again?
Oh, sorry. Undefined method run. Let me rack up. Wiki. Up equals proc use run up. Yeah, it should work. Proc Ah, yes. Sorry, it's the file should be RU and not RB. Backup Ruby hello RU. Sorry. So it's supposed to be a rockup file, whatever. So I have this port 9292, and let's try and see if our console is working. Docker run this box. No, let's run Ruby bash ing. How did I call it? Ruby hello. No, doesn't work. The idea is it doesn't show the port.
Press the notes. Note 1.
It's on the here.
You said 92.
Ah, yes. This is the health check, and then here we see the port, but it doesn't work. So unfortunately, I cannot ping this, and it's supposed to be service.console big. Maybe it's dash. Big. Doesn't work. Sorry. But that's the basic idea. We have a service that returns hello world. Now, the API of this service is you do an HTTP request, you get a reply, and the reply looks the same. It always text HTML. It always replies with hello world. If for some reason we want to rewrite the service in a different language, we can maybe the same port, but we can rewrite it in Python, and it would be the same service, right? Or maybe we can rewrite it in Go. Now, nice thing about Go, let me demonstrate. I'll be able to make this work. Docker run Golang. Go hello go. Go run. This is what happens when you do changes at the last minute. Anybody knows Go? Because I made the change here. It was not printf. It was something else. Tell me which letter. This printf to W is wrong. It should be not printf. It should be something else.
S printf.
S? Big S? Small p. Okay, let's try. It's not S. Golang, blah, 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 FNT.
For Go, you need S for strings.
No, those strings, writer.
It's a writer which is supposed to write to fprint. It's supposed to be fprint, not fprintf. Yeah, it was fprint. Oh shit. Cut. Go hello go. It was fprint. I removed the F instead of removing this F. I removed that F. And go run. Well, URL localhost. What is the port? 8080. Ah, finally a hello world. Thank you, thank you. Live coding is always hard. So this is the same service written in Go. I wanted to show you something really cool about Go. Okay, so let's what's nice about Go is when you build something, see, you get executable that has some dependencies on dynamic libraries. But if you build it with LBD flags, I think, -s, LD flags, -s, then I should force rebuild because it doesn't rebuild normally. This forces a rebuild. Anyway, the nice thing about Go is that you can. There's a link at the end of the presentation. You can compile this to have completely static libraries compiled within, which means that you can use the Scratch Docker container, which has 0 bytes. Just put this executable, this one executable in it, and that's it. That's the whole service. It takes 4 megabytes. That's the whole service. It only takes 4 megabytes. That's what's nice about Go. You don't need all the extra stuff that Ruby has, and USRlib Ruby and USRlib Python, and all the dynamic libraries and blah blah blah. Node, yeah, and Java. So basically, when you have a microservice running in Java, you need the whole JRE and the Linux runtimes user space, and you have something in Node, the same in Python. With Go, you have 4 megabytes. You don't need any user space. You don't need to have a Docker image.
Like C, that way. Yeah, you can do the whole thing with just have only C stuff.
Actually, Go is more like event machine than C. It's not really C. So basically, what's nice about Go is you can have microservices being really small, which means you can deploy them even faster, and their images would be like 1 megabyte, or I don't know, 10 megabytes. And that would be the whole microservice. And that's really, really cool, because in Docker, you can create these Docker images that take 0 space, 1 executable in Go, completely statically compiled. That's it. That's your microservice. It can talk to the database. Basically, what Go does, it has all these libraries talking to the database, to Redis, to network, whatever. And when you compile, it compiles everything in the executable. So you get just 1 executable that has all this stuff inside. Really nice.
It's exactly the same with any static language, like C, C++.
Really executable. Yeah. So here's another Python microservice. What this microservice does, it talks to Redis. Now, as you can see, this application initializes, I don't know, it basically, when we are using console, this host Redis could change over time, right? Because it's dynamic. Because the configuration of who is this Redis in DNS keeps changing when we create new containers. So when we write code like this, we need to make sure that we requery in our, first of all, we requery who is Redis once in a while. And when we fail to query who is Redis, we retry, or we get some generic return that says, well, I didn't find Redis, but here's the number for you, or something. We need to have these fault conditions about other services missing to be embedded in the application. It should be, how's it called? It should protect itself from missing dependencies that are external to itself. So it's a more rigid defensive programming. And of course, the port here, if we are using console, we need to query the port from the DNS as well, or via the HTTP API, because that might not be the same port. We cannot hard code it like this. And what this service does is each time you call it, it will show you how many times it has been called. because it saves that in Redis, and I wouldn't try to run this right now because it will probably not work for me. But this is the basic idea. This is a small microservice that says I have been called X times. Any questions about polyglot services?
Just a question about the best practices. Whenever you do this bin bash, then you change the Docker from side, right?
I'm in the container, yes.
In the container, isn't the best practice would be like to create a run file or the executable, and then to, I don't know.
Yes, basically you would.
The Docker with it.
In your production system, you would not be starting containers manually, going into their shell and creating files. You would probably create that as an image using a Docker file in a build system, etc., etc. That we covered that on the previous workshop. Any more questions? Notes? No? Good. Let's talk about other interesting services. Composing service. What would the composing service be? Any ideas? It's okay. It's a guess because I invented the word.
Compose something.
It would compose stuff, yes. So basically, the idea is like this. When you go to a large website like Facebook, Google, Amazon, you have a lot of snippets of information presented to you. Okay, you're the user, and you look and you see there are like X amount of results, and then you see the dictionary definition for the word that you're looking, and then you see some results, but then you see like this in the news thing, and then you see images, and maybe you have in-depth articles, and then you have related searches, and you have pagination. Now, would it make any sense to have all of this as one monolithic application that calculates all the conditions? Should I show the dictionary or not show the dictionary, and then show it to you? And then you would have this one layout, and that layout will need to compose everything together and maybe show stuff and maybe not show stuff. That would be really difficult for a monolithic application to get right. And most probably Google are not, they don't have one monolithic code base, service that returns all these results. These results get generated by multiple services. One service for dictionary, another service for related searches, right? How many services do they use to create one result page? I don't know, but a lot, I guess. I don't know. Maybe Avishai knows. Who? Twitter, yeah. Okay, so Avishai says 2 years ago, Twitter said that a page in Twitter was 42 services responsible for creating the content that you see. It's a small number. It's a small number. I think Amazon also published something. It was in the hundreds. I don't know, a couple of hundred. Which basically. There is a service responsible for dictionary results. So when you type a word, there's a team in Google, I guess, I don't know, but I guess, who maybe, in some cases, say, oh, this word, we know it, we want to add to the result this dictionary snippet. Now, this team doesn't need to synchronize with the other teams. It doesn't need to go to the team that is responsible for the actual results from the internet, the search engine, the result pages. They don't need to talk to them. They don't need to tell them, well, you know what? Sometimes you should show our dictionary at the top, because that would be a lot of synchronization. A huge company cannot afford itself to do something like this. Small company can, but larger companies it becomes really problematic. So one service that can help compose this is a composer. What's a composer? It takes different results from different services and composes them into one result that gets sent to the client, the one HTML page.
All the composition can happen in the browser.
Yes. How?
The same logic.
Yes, but what methods would you use in the browser to compose a page?
Ajax.
Ajax. Other methods?
WebSockets.
WebSockets, maybe, yes. And JavaScript, right? Yes. What else? Think 95-ish. Iframes. Oh, come on. You're so good. You could do it with iframes.
That was so bad brought up.
But okay, what else? Any kind of server-side ways of doing it. Composing. We're talking about composing. No? 95. Yes. Server-side includes. This game is so good. Any how's it called? Modern server-side includes that you might be aware of, especially if you're working with big CDN companies. ESI, yes. Edge-side includes, which basically you create stuff, you give it to Akamai, and they do the composing for you. It's like server-side includes, but it's Akamai proprietary specific thing and Vanish. But what about JSON replies? All of these, they don't, like when you ask a server for an API that returns JSON, can you use Ajax? No, because you ask for a JSON and you want to have composable parts in that JSON reply. Can you use Ajax? No, it's not a web page. Can you use iframes? No, it's not a web page. Can you use server-side includes?
I'm guessing you can.
Yes. Yes, you can. Both Nginx and Apache have server-side includes. But can you use server-side includes to compose a JSON response from multiple services? Come on, anybody? Yes and no? No, Nginx has SSI module that does server-side includes. I'll show it to you in a second. Nobody wants to answer my question. Yes, you can use server-side includes to compose multiple responses of JSON into one big response of JSON. Why not? Yeah?
To compose a JSON response.
Yeah, to compose a JSON response. I guess.
That's the key would be.
Huh?
Exactly. It's not.
It's complex, but it can be done. Yeah. Also, you don't have to do the server-side includes in Apache or Nginx. You can do server-side includes with PHP. Why not? Or with ERB, or with a service that can compose stuff. Why not? Why would you want to use a composer service? We talked about it at the beginning. You can, for example, get multiple services giving you a response, and then you give one result to the user.
Reverse proxy, internal architecture, caching.
Yes, but it's a reverse proxy of like one request and fan out requests, and then you gather all the requests and you return one response. It's powerful stuff. You can do a lot of really good stuff with it, especially websites today that have this sidebar and this, like we showed it with Google. Okay, have a lot of things. So there's somebody wrote this in Node.js. I don't know why. They called it Composure, and basically you ask Composure and then it has some configuration that says get this part from this service and this part from this service, and it can also cache stuff. So it's not really a microservice because it has so many responsibilities, but that's the way it works. There's a link at the bottom that explains why it's cool. And I wrote myself something in Go. It took me a whole day, and I learned Go. And maybe I want to show you how it works. I don't know. Let's try and go exercise. So, you know what? Let me just read you the code, and then you can decide if you want to try it. So as you see, there's a handler here. It serves the whatever SSI function returns. The SSI function has a request coming in, and it writes a response back on every request. Then there's something called templates in Go. What's a template? It looks like this, and each time you do this double brackets, okay, you can write expressions here that are part of the. So this SSI is a function that I implemented and I provide to the template. So template has, okay, you have the SSI function. And there's this is the template, combiner HTML. It has two divs. One of them shows half of the screen is Google Plus and half of the screen is Facebook. And what this function does, the SSI function, it creates a new HTTP getter. It goes to Google Plus, gets the HTML. It goes to Facebook, gets the HTML. And this composable thing, well, of course, don't use this in production. It's buggy and stuff. But basically, you can define any kind of layout and compose multiple services into one output. And if some of you saw the Spotify videos, they talk about they have these culture videos. They talk about this a lot. That they have given every team their own kind of, you do this service, and in the end they have one combiner that combines all the outputs into the application of Spotify. I won't run this. I'll save you the time.
It seems that there is a single dependency again. You want to add some part of the one responsible for this template or adding you to the template.
Yeah, well, you need to have someone who knows how to integrate the services. No?
Dependency.
Yeah.
Business logic.
This SSI implementation is very naive. I wrote it in a day, but it can be much more complex. It can have conditions and etc. etc. Fault tolerance is important in all services. So when this service cannot get Facebook, maybe it would fall over to get Orkut or something. I don't know. And as I showed before, yeah, this now what I didn't define here is which API endpoint this is. So this basically responds to it's not here. this responds to slash, right? But this doesn't have to be in my application to be the root, because this is just the composer. What if I want to have mywebsite.com/compare website/Facebook/Google? Okay, it can use the same composer to do this, and pass the parameter in, and this this template is configuration basically. This is not the code. This is not the service. This configuration could come from a different place. So this code could get the templates from like Akamai. Akamai, with their ESI, you send them your templates and they do the includes for you. So they have the composer service, and you give them the templates. Okay. Of course, Akamai doesn't know your business logic. They don't care. It's configuration for them. Okay. Another service, API Gateway, which is a microservice pattern. So Netflix wrote a while ago, a couple of years ago, how they refactored their APIs, because their APIs would give you snippets, they would give you like small parts of things, and you had to combine them yourself on the client side, so you had to do multiple requests. Okay, so you did multiple requests, and then multiple services in their API would respond to you, different services, and you would combine your own answer. When they did this refactoring, it's documented here in this link. They basically tried to save on this complexity, to move this from the client side to the server side, and they also removed 20+ redundant services that they didn't need anymore. And the questions became like one question, much bigger answer, and much faster in response to this answer. How they managed to do this with, say, they have API versioning, right? But they have all these services behind their API endpoint. And they didn't want to rewrite all the services, right? It's not a monolithic application. They want to leave the services as is. They just want to change the interface in a new version of the API. And they would still use some of the old services. So a couple of months later, they released to open source something called Zool, which is a composer. Like, it's both a composer and a router, I guess, and it's much more than that. But it sits behind the load balancer. Of course, there are multiple Zool instances. And it has a dynamic configuration that defines each URL endpoint where it would go. So if they have some service that is not yet implemented and they want to test that with their mobile, they can write it in Zool, return a static JSON response, and when the server guys would finish the server, Zool would redirect that to the actual service. So if you're looking to do some complex combining and routing and rewriting and etc., this is an interesting tool to look at. And how it works, it gets a request. It has this whole pre-filters part, which is written in Groovy, if I'm not mistaken. Then it has the routing filters, which defines which service it would go to. Then it has post filters, which defines how to treat the answer. Maybe the answer needs to be changed. And of course, all of this, if there's an error, there's a filter of error that says, okay, there was an error, I need to provide a different answer. And the routing filters will actually talk to all the different services in the backend, and then you would get the response. And this Zool is a service scaled out to multiple instances, sits behind the load balancer, and all of these origin servers are also services who are behind the load balancer, scaled out, etc., etc. So this is a complex composer thing and router. Both, I guess.
This because it's GUI files.
Yes, it's GUI files.
You can change them without any
Restarts.
Restart.
Yeah.
It will automatically.
Yeah, and these filters, the GUI files, they can come from some other service or something that will change them on its own. It doesn't have to be a human who goes and changes things. So it's an interesting example of how you can enable microservice architecture. And because we didn't run the code examples in Ruby and Python and Go, I think that the workshop part is done. So if you want to close your laptops, you can, because from here onward, it will be a couple of slides with a lot of bullet points. So brace yourselves. Or you can go. Anybody knows what solid is in OO programming? Nobody. Nobody is a programmer. Nobody ever heard about solid principles. Really? Anyway, there's this thing in software programming that, about object-oriented programming that people have spent a lot of time thinking about how, like, for example, any of you know that goto is banned, that you shouldn't use goto? You know that?
XKCD told us that.
It was a long time ago, right? You shouldn't use goto. So some people came up with ideas what you should do. And they created this solid principles thing, which apply really nicely to microservices as well. Basically, when you want to take one monolithic application, maybe object-oriented one, and split it up into multiple services, if you follow these principles, you would be in a very good shape. So first principle is single responsibility. If you want to change a service, there should be just one reason to change it. So if you have a service that creates reports, and you want to change the database behind that, right? Or you want to change the PDF that it creates, that means it's not a single responsibility service. It should be two services. One of them should be the data access, and one of them should be the view report generation. Risk of substitution basically means that if you have an interface, you can replace whatever is providing you that interface. For example, Ruby replaced by Python, and the interface would be the same. Okay, so you have these promises, so to speak. Interface aggregation means that, as we talked about on one of the first slides, every service knows as little as possible about its surrounding and other services. Okay. And dependency inversion is what we saw with console that can go in and change template files, or with API gateway that can route things to different endpoints. It basically means that the server itself, it doesn't know how it will be, in the end, how it will be accessed. It is something that is, I don't know the word. So basically, the service is not responsible about how it will be used. Who is eventually? Who is responsible is somebody outside of the service. Even though I'm a really bad explainer of this, you should watch a presentation of what's his name? Robert Martin, Dr. Bob? No? Uncle Bob. He wrote several books about this, and he has several presentations about making just generally good software architecture, and it talks about the solid principles. It's important. If you want to do microservices in a good way, you should probably at least be familiar with this. And some other patterns of microservices that I didn't touch. Circuit breakers. Anybody knows what it is? Circuit breakers? Fusing, yes. The thing at your home, when you have a spike of electricity or you have a malfunctioning electric device and you plug it in, what happens to the electricity in your home? It shuts down, it gets cut off. So you wouldn't have an explosion. The same thing with services. When you have a service that tries to access a database and the database is not there, what would it do? Well, it can retry a couple of times, but what if it's still not there? Would it respond with a faulty response or would it crash? What would it do? So Netflix have another open source tool called Hystrix, from the word hysteria, I guess, which basically every function they have in their services, if it cannot do whatever it is needs to be done, there's this catch exception thing, and that catch might respond with a default value or might respond with an error, but it would try to lift the circuit back, the circuit breaker back, if possible, at a later stage. So every service protects itself. Okay? Complex? No? We talked already about dynamic external configuration. Basically, configuration is not part of the service. It's external to the service, can change in real time, and it gives you a lot of flexibility. Like with Zool that we just talked about, these GUI files, they can change during runtime. It's super powerful. Like Etsy and their feature flags. So Etsy have A/B testing features that can be toggled on and off. So they have parts of code that can be toggled off, and they would not be working. And if they had to redeploy the application every time they want to toggle off or on a feature, that would not be very scalable for them. So they have this central configuration thing. I think it's a PHP file that they redeploy just that, and that's their configuration. Service discovery, we already saw that. Data enrichment. Basically, sometimes you get, for example, a Facebook check-in into your application, and you want to process that and do a complex computation that will find all the friends of friends of friends of yours and create an aggregation out of that, etc., etc. It would be very costly to do that during the request response cycle. It would be much nicer if you could just say, like, put a note on the side, somebody please do this very complex computation and change the database with the result, and later we'll use this result. Too abstract? No? Yeah, asynchronous process. So this is another pattern for a separate service to be doing. Or you can have this one flag, a user has been added, and then 500 services would take this from the queue and do something with it. Not just one asynchronous process or two asynchronous processes. On each event, you can have multiple services doing something in response to the event. Now, what would a microservice require other than its own business logic or its own responsibility? It probably needs some kind of communication, so you could talk to it, right? It can be REST, but it doesn't have to be. It can be a queue. Okay, you can talk to services using a queue. You can talk to them using protobuf, using a SQL, whatever. If you are doing microservices architecture, you probably want services reporting about themselves, like I have logged in users for 100 times for the last hour. So you could query, like Docker, you could query Docker, its events API, and say, what are you doing? And it will say, I'm creating, I created 2 containers now, I created 2 images, etc. You probably want to have some kind of output about what's happening with the service. and that might go to other services, or other services might come and take the logging out of the service. That would be the list of substitution. No, yeah, that would be the list of substitution principles. So the service itself, it has logging. The logging of all the services is the same, but other services come in and take that logging. The service itself is not responsible for sending its own logging to Logstash. Logstash is responsible to going to all the services and taking out their logs, because that's his responsibility. Of course, managing change versions of services, important. You need to have some kind of thought process around this, and the deployment and rollback, especially with scaled out processes when you have a lot of them. How you deploy a new version, how you remove the new version if it didn't work, and revert to the old one. Ugh. I will improve these slides for the next workshop. I don't like bullet point slides. So infrastructure, we already talked about server service fit. Some services need memory, some services need CPU. Multi-tenancy. When you have Docker services, you can run multiple, I don't know, memory-intensive services on the same host. Yes?
In order to build a microservice, you need a lot of supported services. There are Microsoft that can give us all these services and leave us with the internet only one service to do it. And we have Redis.
Okay.
Redis have one service to use. We need the login, we need the
yes. Yes. Actually, one of the first. Yes, that's why at the beginning of this, I said this is all very complex. There's not enough tooling yet for doing all of this. Some companies have released some tools, as you have seen during this presentation, but there's a lot more to be done to make it simple. And at the very beginning, as I showed you, when you take something monolithic like Ruby on Rails, you get a lot of stuff for free. And when you want to move to a much more microservices-oriented architecture, you would need to do a lot of work to fill in the gaps of something that Ruby on Rails already gave you by convention. And yeah, and there are a lot of solutions, but none of them are perfect. And you need to invent your own conventions at this time, because nobody came in like Ruby on Rails and says, well, these are the conventions, everybody does this. It doesn't exist yet. There are a lot of different conventions in different parts of the architecture. So for Docker, there are Docker conventions. And for logging, there are, I don't know, logging conventions. But there's nothing that is like, this is the stack of your microservices.
But there are vendors that are trying to build the next past generation, like OpenShift. You know,
yes.
They're trying to assemble
Cloud Foundry and the Spring Cloud. Yeah. So Spring Cloud, they released version 4, and they said, this is the microservice Spring. We give you all the conventions, just use the Spring. It already has Zool inside and Eureka for service discovery, etc., etc. And then you say, but I don't want Eureka, I want console. No, sorry, the convention says Eureka. That's how it works. Hopefully next workshop we'll talk a bit more about tools, which you could use your computers a bit more. Try to install Mesos and Kubernetes. We'll see how that goes. There are some references. I'll send the slides in half an hour or something, and you can look up. I dug up a lot of information to get this summary of microservices, and there's a lot more information. It's just mind-boggling how big this topic is. So feel free to watch some videos, read some blogs. For those of you who want to stay for a bit and create maybe a Docker registry, a private Docker registry, there's a bonus slide. Nobody raises their hands. One? Okay. So This is the bonus slide. If you still have your computer. It creates a registry, but the nice thing about private registries is how you use them, which is I don't have it here. It's in the cheat sheet. Docker, actually no, Docker push and no. You need to change the. I don't know. Maybe I'm stupid, but you need to change the name of the. You need to tag your image with a name that includes the host name, and then you need to push there. Unless I'm mistaken. Yeah, it's.
By the way,
Yeah. But then again, why would you need a registry? Registry keeps images. Now, who would build the images? You need a build server. Say Jenkins. What would that build server do? It would go to your version control. Maybe there's some Docker files there. Maybe your microservices are in Python or Ruby or whatever. It needs to, or Go. So it needs to compile the Go code, create the image, and push it to the registry. All of that would also be like a service that pushes stuff to the registry, handles versions, etc., etc. It's a whole part of infrastructure of Docker that right now you can use some SaaS solutions like I think Quay.io or something. But if you want to use Docker in-house, you need to build all this infrastructure part yourself. Or pay me, I don't know. But basically, you need to build it yourself. The build and the registry and the understanding how Docker layers work if you want to save up some time and space. Anyway, I hope you enjoyed the short workshop and a lot of bullet points. And you will come back again. But this is it. Thank you.
Thank you. Still downloading images.